welcome back. This episode we're going to continue on the Strat that I started building in the class that I'm teaching at a local community college that was rudely interrupted by some national/international pandemic. Anyway, I forgot to mention last episode, this guitar is going to be named Belle, B-E-L-L, and primarily my inspiration for names comes often from either people I'm making them for or something that the guitar reminds me of. But in this particular case, it's because we have a bird's eye maple neck top combined with a leopard wood fretboard combined with low output vintage S-style pickups from Rio Grande combined with my extra boost circuitry. If you add that all up, equals Belle. Seems like a perfect name for this guitar to me. Anyway, I promised you that we would work on the neck contouring. Now, when I was teaching the class, I did get as far through the class where I showed everybody how to contour a neck with hand tools. Okay, basically with a pocket knife and fishing line. No, that's not true. But with the standard luthier tools that you would use by hand. Spoke shaves, files, rasps, sandpaper, other apparatus to kind of help out with those things. And so that's what I taught in class. And there's other videos in my Telecaster series that you can look back where actually Matt of Texas Toast and I got together and compared and contrasted some differences in neck contouring that we do. So you can go back and look in that if you're looking on how to contour a neck by hand. Let's talk a little bit about the difference between carving the back of the contour on the neck by hand versus using a jig versus using a CNC. If you're just building one or two guitars, you're going to build them by hand. Okay, you're going to carve them by hand. You're going to use files. You're going to use rasp. You're going to use spoke shaves, whatever other tools that you have readily available to you. And you're going to follow the dimensions of your favorite guitar or a spec, that you just wanted to try out, and you'll get pretty close, but you really have to be careful about having very linear and consistent lines. Where a jig helps out is it can help me produce absolutely parallel lines by controlling that axis of the neck carving process. A CNC is going to give you the most production and the best absolute repeatability where every single one of them is going to be exactly the same. And my preference is to use the CNC for a lot of the necks that I make because I'm making primarily the same specifications on most necks that I make. Now, if I have a client who wants a neck that is unique, let's say it's either unique dimension, let's say it's a unique shape. Maybe it's not your standard C or D, maybe it's an asymmetric neck or anything. And let's say I don't already have those files and the CAD programs and the CAM tool strokes built out for that unique specification on my CNC. Well, it will take me less time to make new templates for my jig than it would to reprogram something for the CNC and test run and everything like that. So a jig is still kind of a tool that I like to do, even though a lot of my necks are done on the CNC nowadays. And I'll show you this jig. We'll try to zoom in a little bit, and I'll give you close-ups as necessary. But I have people asking me all the time for plans on my jig, and I'm telling you, I never produced plans. I actually took concepts from other people and other jigs that I saw out there floating around YouTube and other forums on the internet, and I combined things to create something that suited my purpose, and I do not have plans for them. Maybe someday I'll figure it out and I'll produce plans. Maybe I'll sell them. Maybe I'll actually make these things and and you assemble parts, I don't know. At this point, it hasn't happened, and I don't see any time in the near future where that will. The overall concept to my jig is to create a platform that will support the neck, that is perfectly flat, perfectly straight, and has a rotation axis to it so that the router can follow these templates, the neck headstock side and heel side can follow these in a rotation that allows that conical taper of the neck to take place. And it's a little bit more than just a conical, okay? It produces a slight offset to that, which is allows how the neck gets wider, but also could be flatter at the same time. And it produces those type of angles. Now, I can't tell you the math that's involved in this because someone much smarter than me figured out the fundamentals of it. What I did is after building this jig is I produced a lot of these removable, replaceable template guides that we've called pucks, and I play with the design and adjust the dimensions of it until I get the result that I want. Now, typically speaking, each time I change, I keep the width the same, but I just change the profile of it. And in this particular case, this is one for an ultra thin neck, kind of like a Parker Fly that I've owned for years, where it has, it's like 19 to 20, very thin, very flat profile. Okay, not much taper to it. And I've taken this one and reproduced that, so that produces a 20 millimeter 12th fret area. And you can see this other template is fatter and taller. Actually, it's the same width, but it's taller. And it kind of bows out there nicely. This produces my standard go-to, which is about 24 millimeters at the 12th fret. You know, plus or minus 23 to 24, depending upon what I want out of it. And then I typically use something on this side, which will get me anywhere from a 21, 21.5 profile on the first fret side. So I've done this through experimentation. Now, what happens with this is the neck gets positioned onto this template in a very specific spot. For my standard bolt-on series necks, I have these guides that help me center this neck perfectly in the middle of that apparatus, and also help hold it in place because it provides a clamping action on the back of the fretboard that's poking out the end of the standard fretboard design. I will then also have a hold down that goes over top of that will clamp and hold down on the heel portion of the neck pretty firmly, so you don't want this to shift and slide and move. And then on the other and the headstock end, I have a couple different clamping calls that I've developed. One is a flat one for the fender style, and then another one for my necks that I make with an angled headstock. I basically have an angled that matches the volute area of that headstock, and it would kind of cradle it in there and hold that into place. So those are just different hold downs that I've adapted for whatever works for me, and that's what you have to do. The concept of the template, the jig itself, is that when the neck is mounted on there, and then we have a acrylic cover over top of this that the router sits on, it produces a platform that will then rotate, okay, and it will swing out as necessary to create the arcing motion that's required for these necks. Now, it has the ability to go down, extend down, but the bottom line is the final passes is when it's in the fully up position, and those what I call feelers basically are rubbing against the pucks, the templates, and that will produce that. So that's kind of the idea to it. So we're going to get this neck set up, and we're going to bolt it into place, and then we're going to double check that it's centered, and we'll get ready to go on that, and then I'm going to show you the router and how that's configured. All right, for the router, it really doesn't matter what brand or type of router that you use. A plunge router is the best because you have to do successive passes in this. And so it's easier to be able to have a router that can adjust in maybe 2 millimeter increments, and each pass across the neck you take off maybe another couple millimeters, really light passes until you get down to your final dimensions. So that's the key that we're looking to accomplish right here. Now, for the bit, what I'm using is basically just your standard round nose, 1/2 inch, solid carbide CNC bit. And that's going to produce about the best finishes that we can. I used to use a flat bottom bit, and theoretically that could produce a great finish, but the bit would have to be much larger so that the surface, the flat surface of the bit, doesn't ever go into the wood on the edges. It kind of keeps to the center, but that's not practical. So what the round nose bit does is it produces tiny grooves that you'll have to sand out. You can get away with a lot of those in the sanding process, and just be careful and do multiple passes at minor adjustments, and it'll remove a lot of them, so there won't be a whole lot left. But that's the best bit for it. Now, recently I had a question on my video, what do I use for an extension? Well, the question probably is first is, why do I use an extension? I think you'll see the system that I built has to reach further than what my router or a standard bit would have the capability to reach. So this extension is 1/2 inch to 1/2 inch, really beefy. I mean, this thing weighs like a pound by itself. And this is made by CMT, made in Italy. And it looks like the part number is 796.001.00. And it is basically a 1/2 inch to 1/2 inch extension, and that gives me the length that I need to make this happen. For the top that I have for my jig, it has a 1/2 inch acrylic, and you'll see that in a second here, that has a slot cut out in the top. That slot is designed to allow a bushing guide. Now, this bushing guide is the largest that came with my Festool router, or maybe it didn't come with it, but as a kit. And it's either 30 millimeters or 1 3/16. Anyway, it's huge. And the idea is I need that to follow the dead center of my jig. And I need to now insert that. To have the reach, it has to be on top. Now, I have to be careful because if you can see, this won't even reach at this point in time. So I have to lower this entire router enough where I can get the extension to seat far enough in and have enough adjustability left over. So let's bring it, that's all the way down, but I don't need to be seated all the way. So I'm going to be seated about 1 inch, and that'll leave me about a 1/2 inch of adjustable space here. If we look at this when it's touching, they're actually exactly the same diameter. Now, I don't know, I wasn't smart enough to really plan it to be that way. It's just the way it works. So as far as my acrylic template goes, neither one is going to be sticking out further than the other. So it really works excellent. But you'll see from my contact point of metal to metal, which always creates a weird sound that you don't really want to hear when you're woodworking, to all the way down, I actually have about a full inch, maybe a little bit more of travel. So it gives me plenty of reach to get down to where I need to on the template. Okay, the neck is mounted properly in the jig. And now we're going to take the top and we're going to position that right on there. Now, this becomes a very rigid sliding surface because I made it out of 1/2 inch thick acrylic, and you can see the top is resting and glued to the two sides. So therefore, there is no bow and no flex within the center of this. Very rigid, and that's important. If you were to get bow or flex, you're going to dish out that neck, and it's not going to be as linear as what it could or should be. Now, the router base is going to ride directly on top of this acrylic, so what I like to do is polish it up before use with a little bit of paste wax and get that nice and slick so it moves back and forth easily. So we'll go ahead and do that. As you can see, the router will drop down and ride firmly and safely on top of this, and it'll glide back and forth. I mean, really easy. 2 fingers back and forth, nice and easy. And this will make that process pretty straightforward. The slot that I have in the top of this only extends where I want it to go for the heel side and the transition to the headstock side. So I could have made it longer and had more adaptability for other purposes and things like that, but this seems to work for me, so I just haven't messed with it. You know what they say, if it ain't broke, you know the rest. I have it set up right here where the bit is extended all the way down and touching the surface in vicinity of the 12th fret. If I slide it all the way to vicinity of the 1st fret, and you look at the gauge, the feeler, to the pucks, we have about 3, maybe a little bit more than a 3 millimeter difference. So therefore, what that's telling me is from the 12th fret to the 1st fret is that I will have a transitional slope of a little bit over 3 millimeters. Here's my target. Okay, so what I'm looking for at the 1st fret, I'm looking for a target of about 24 millimeters. And at the 12th fret, I'm looking for a target of about 21.5. That's a difference of 2.5 millimeters. Okay, this is before sanding. So my actual should be right there, which means I'm going to have to make these about a 1/2 millimeter extra for sanding. So either way, I've got a difference of about 2.5 millimeters. So I'm a little bit over a 1/2 millimeter different than I really want it to be. So here's how I can adjust the entire template easily. I could create new pucks that better align with those, or I can take some tape on this side. Now this is that binding tape, the paper-based binding tape, and I got 4 layers on there, which just so happens to equal approximately 0.6 millimeters. So I'm going to put that on this side, and that's going to elevate it just a little bit on that one end. Then when I put this back down, and I go look at the same thing that I just looked at, the gap that I have has closed. Now it's going to be closer to the 2.5 millimeters that I'm looking for. I will tell you straight up that I'm a fan of the dust collection. So I built this top encasement with a 2.5 inch, whatever size it is, dust chute on it. And then I hook up my portable dust collection system to it. And that creates enough suction in there that I get most of the fine dust and a lot of the debris, but what I don't capture, I would say almost all of it at least remains inside the box. So it really helps clean up the outside environment and be a little safer. So I really like that. Okay, from the whiteboard that we looked at, we saw my beginning neck thickness was 25.3 millimeters, so just a hair under 1 inch. And I want my final spec to be right around 24. All right, so I just adjusted it to be able to go down 1 millimeter more than where I was currently touching the wood. So that should get me really close to the specifications. If I have about 2.5 millimeters of clearance on that side, plus that millimeter, that means I should be removing 3.5 millimeters. So 25 minus 3.5 is about 21.5 plus a couple tenths of millimeters. That should be about right on the money. All right, it's going to get noisy here, and I'm going to do this probably in super quick time lapse because it gets kind of monotonous to watch it over and over and over again, back and forth, but the same process, back and forth, rotating around as it goes, will knock off all the corners and then get it down to my final specs in a perfectly linear fashion. That's what we're looking for. All right, let's get it going fast. Okay, all in all, that's, I don't know, 5-7 minute process. I really wasn't keeping track of time there. A lot of trips back and forth on this thing. But we've got a very linear contour to this neck, which is what I wanted. And we'll have to take it out to measure just to make sure where we're at. But we should be right on the target that we need to be. So looking through the acrylic, should be able to see a little bit of lines, machine lines back and forth. That's no different than you get off of a CNC, to be quite frank with you. The only difference is they're going to be a little bit more consistent on the CNC. This is more freehand, and the rotation, me controlling how many lines and the density of those lines. So, you know, the more passes I take and the better I move my left hand, the better it will be. All right? The key thing to look at, though, is really there's no dust anywhere outside that box. And to me, that's one of the favorite things about this jig, is the fact I can do a very messy operation with very little dust. I mean, I'm still clean, you know, so it's all right. The only thing I really have left to do is these transition areas at the heel and the headstock. It'd be really sweet if I could figure out a way to get that to ramp up automatically, but that's why I have a CNC. You know, I mean, if I really needed that level of detail, I just program it in and have it done exactly the way I want it. So for this is really good because it can be quick and easy to adjust your puck size or shim it out, you know, if you need to on one side to kind of make little tweaks, and then go ahead and rough it out, hand carve the transition areas, sand it down, and this neck will be ready to go. So it's a much quicker process if you've got something that you're doing that's a little bit unique and not part of a CNC program, or if you don't have a CNC and you want to produce necks that are very similar from one to the next, this is another way to do it too. So there it is. There's the contour, and that feels pretty good. Let's measure it. Okay, I've got 21, so a little bit less than my target, and 24, which is right on my target. So it's right where we need it to be. It's going to be a really comfortable, kind of a modern C, you know, pretty fast-moving neck, but traditional enough to be comfortable to pretty much anybody. So there it is. Okay, I totally was just going to end that video right there, right at 24 minutes or whatever the heck it was, and call it good for the neck contouring. But in the time that I filmed the footage for that neck contouring a few days ago till right now when I was doing the post-production, I read some of the comments and different questions about specifications, measurements of the contouring jig and things like that. And I thought, well, why don't I add a little section on the end? And I'll tell you, I don't have every single measurement, but here's what I'm thinking. And if there's enough demand, we can do this. But I'm thinking what we can do is, if you really want more questions answered, we could try to do a live YouTube session where I break out the jig and I go over all the different pieces and parts, and you guys can ask me questions, because I don't know everything that needs to be covered and can't go into detail, and maybe we can do that. Now, I've never done a live YouTube before, so I would probably ask my friend Matt over at Texas Toast to come on over and help me with that for that first time, and just make sure I got all the technology worked out right so that it works. But if anyone's interested in that, post a comment, let me know. Go talk to Matt over on his channel, and you know, kind of encourage him to be interested in doing that. I'm sure he would, but you know, it's a question of timing, and he's super busy and I'm super busy, and we got to make schedules meet. But that might be a possibility. So what do you think about that idea? So since we're here, let's just cap off this video with what I did over the last several days after we left on the original footage of using the contouring jig to contour the back of the neck. And we've got the neck right here. It's all been sanded. And I'll tell you my process, and you can look back to my Telecaster series. There's a video, and I forget the number, but you can look it up, and it's the one where I'm actually doing the final sanding to the neck on the Telecaster, and I'm doing exactly the same process as what I showed in the second half. And that's using a DA sander, and I worked myself from 80 up to about 180 grit. No need to really go any more than 220, unless maybe you're doing some special oil finish. But let me pull out some naphtha and get you guys close to see what this neck is looking like now. So here it is, a little naphtha on it, but you can see how smooth that is up to 180 grit, and the transition areas, how they all come together. It's going to be a beautiful neck. And just in case you forget what the front looks like, there's the fretboard and the stainless steel frets with that leopard wood. Pretty cool. So next episode on this guitar, we're going to work on the edges. I had a question that I was fielding in the intro video about binding versus round over. And it sounds like a lot of people want to see a faux binding, which wasn't one of the choices I gave you. But next episode, I'm going to show you, and we're going to attempt to do that. And I say attempt because we're going to explain it in the next episode. All right, until next time, remember, no matter what you do, start with excellence.